All right, hello, my wonderful students. This is section 7.2, properties of exponential functions. This is foldable number 1. So we'll go ahead and get started with this one. The first one here, we're going to be looking at how the negative affects the parent function. And this one's a little bit different because we're using this function here, which is the same. The y is equal to ab to the x power, but the parent function is not always the same. The parent function is basically based off of the b. So whatever, let's do that in blue. So the parent function is going to be the y is equal to b to the x. So it can always be different because this b can change. It can be like, for example, here it's 3. It could be 2. It can be 7. It can be 9. It doesn't really matter as long as this here is recognized. And but in this case, we have this one here. So we're going to go ahead and graph our parent function first, and then we're going to graph our function with the a embedded. So let's go ahead and just create a table. Let's do that now. We can do this here, and we'll go ahead and do our x 3, 2, 1, 0, 1, 2. Or, let's just do -2, -1, 0, 1, oh, not +1, sorry, and then 2. And then we'll do our parent function, which is our y is equal to b to the x power, and give us a little bit of space so we can actually, do calculations if we need to. And then we'll do our y is equal to a b to the x. Well, we're using this one here, so this actually here is going to be equal to 3 to the x, and this one's going to be equal to -1/3 times 3 to the x up here. Just get that out of here. Alrighty, and then of course we're going to have hit the recording studio box thingamajiggers. We're also going to have there we go. We're also going to have our graph on this side, which we'll graph once we have the points. I mean, I know it's going to be something like this. We are going to go down a little bit, so we're going to do something like this, and like this, and 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 1, 2, 3. I mean, we're only really going to go to 2, but just to put it on there. All right. So the first one is 3 to the x, so it'd be 3 to the -2. Let's just do it in different color. Let's do it in green. So 3 to the -2, which ends up being 1/3 squared, which is equal to 1/9. We have 3 to the -1, which is equal to 1/3 to the first power, which is still 1/3. 3 to the 0, which is equal to 1. Anything to the 0 is equal to 1. 3 to the 1, which is equal to 3, and 3 squared, which is equal to 9. So this is our parent function, so we're going to go ahead and graph that in green. So at -2, it's 1/9, which is really close to the line. At -1, it is at 1/3, which is about right there. At 0, it is at 1. At 1, it is at 3, 1, 3. And at 2, it is at 9, which is like way up here. So we're going to graph our line. So this is going to be our parent function. I guess we could have just drew a line to here where it says parent function. And then we'll go ahead and do our what's it called? Thing in red, the transformation that we're doing. So we're going to do this one here. Now it's going to be multiplied by that. So we have our 3 to the x, which is our 1/9, right? So it's going to be -1/3 times our 1/9, because we already calculated 3 to the x. It's here. So we're just going to multiply each of these by the -1/3. We can actually put -1/3 to all of them. Times, and times. Okay, so times 1/9 is going to give us equal to a -1/27, because 1 times 1 is 1, and 3 times 9 is 27. Negative times positive. 1/3 times -1/3 times 1/3 would give us a negative 1/9. Then we have 1/3 times negative 1/3 times 1 is going to give us a negative 1/3. Negative 1/3 times 3 is going to give us a negative 1, because it'd be 3 over 3 is equals 1. And then we have negative 1/3 times 9, it gives us a 9 over 3 negative, which is equal to negative 3. Okay, so we go ahead and plot that. So we have our, at negative 2, it's like pretty much almost touching the line, but never touching the line. At negative 1, it's 1/3, which is about right here. At, it was negative 1/9, which is still close to the line. At 0, it's negative 1/3, which is about right here. At 1, it is at negative 1. And then at 2, it is at negative 3. 2, negative 3. And that goes here. So this is our transformation. So this is going to be our y is equal to negative 1/3 times 3 to the x power. So we can see the difference. If you guys see, it is a negative, so it is reflecting over the x-axis. And since this is 1/3 is between 0 and 1, you can actually see that this graph got a little bit squished. So this one's a little bit more extended than this one here because it got a little bit squished because it's compressing. If this was a number like greater than 1, like 4, 5, or even negative 4, negative 5, negative 2, it doesn't matter what number we pick, then it would stretch it. It would be a vertical stretch. But since it is between 0 and 1, it ends up being a vertical compression.